Hubble identifies strange exoplanet that behaves like the long-sought Planet 9. The 11 Jupiter-mass exoplanet called HD 106906b involves an improbable circle around a twofold star 336 light-years away, and it could be contribution hints to something that may be a lot nearer to home, a guessed far-off individual from our solar system named Planet 9. This is the first occasion when that stargazers have had the option to gauge the movement of a gigantic Jupiter-like planet that is circling far away from its host stars, an obvious trash plate. The exoplanet HD 106906b was found in 2013 with the Magellan Telescopes at the Las Campanas Observatory in Chile's Atacama desert. Be that as it may, stargazers knew nothing about the planet's circle. This necessary something just the Hubble Space Telescope could do, gather exceptionally exact estimations of the drifter's movement more than 14 years with uncommon accuracy. The exoplanet lives incredibly a long way from its host pair of brilliant, youthful stars in excess of multiple times the distance of Earth from the Sunday. This wide division made it tremendously testing to decide the 15,000-year-long circle in quite a brief time frame length of Hubble perceptions. The planet is crawling gradually along its circle, given the frail gravitational draw of its far-off parent stars. The Hubble group behind this new outcome was astonished to find that the far-off world has an extraordinary circle that is extremely disposed, lengthened, and outer to a dusty trash plate that encompasses the exoplanet's twin host stars. The trash plate itself is extremely uncommon, maybe because of the gravitational pull of the rebel planet. This investigation was driven by Magellan Wen of the University of California, Berkeley. To feature why this is odd, we can simply take a gander at our own solar system and see that the entirety of the planets lie generally in a similar plane, clarified in Wen. It would be strange if, state, Jupiter incidentally turned out to be slanted 30 degrees comparative with the plane that each other planet circles in. This brings up a wide range of issues about how HD 106906b wound up so out of sight quite a slanted circle. The common hypothesis to clarify how the exoplanet showed up at quite a removed and oddly slanted circle is that it framed a lot nearer to its stars, around multiple times the distance that Earth is from the Sunday. Notwithstanding, Hall inside the framework's gas plate made the planet's circle rot, compelling it to move internal toward its heavenly haze. The gravitational powers from the spinning twin stars at that point showed it out onto an erratic circle that nearly tossed it out of the framework and into the void of interstellar space. At that point a star passed extremely close by to this framework, balancing out the exoplanet's circle and keeping it from leaving its home framework. Up-and-comer passing stars had been recently distinguished utilizing exact distance and movement estimations from the European Space Agency's Gaia study satellite. This situation to clarify HD 106906b's peculiar circle is comparable here and there to what in particular may have made the theoretical Planet 9 end up in the external compasses of our own solar system, past the Kuiper belt. Planet 9 might have framed in the inward solar system and was then kicked out by cooperations with Jupiter. Nonetheless, Jupiter would almost certainly have flung Planet 9 a long ways past Pluto. Passing stars may have settled the circle of the kicked-out planet by driving the circle way away from Jupiter and different planets in the inward solar system. Maybe we have a time machine for our own solar system returning 4.6 billion years to perceive what may have happened when our young solar system was progressively dynamic and everything was being jarred around and improved, clarified colleague Paul Callis of the University of California, Berkeley. Until this point, cosmologists have just fortuitous proof for the presence of Planet 9. They've discovered a bunch of little heavenly bodies past Neptune that move in uncommon circles contrasted with the remainder of the solar system. This setup, a few space experts think, recommends that these items were shepherded together by the gravitational draw of a colossal, inconspicuous planet. An elective speculation is that there isn't one monster perturber, yet rather the unevenness is because of the consolidated gravitational impact of a lot more modest items. In spite of the absence of recognition of Planet 9 to date, the circle of the planet can be derived dependent on its impact on the different articles in the external solar system, clarified colleague Robert de Rosa of the European Southern Observatory in Santiago, Chile, who drove the examination's investigation. This recommends that if a planet was in reality liable for what we see in the circles of trans-Neptunian objects, it ought to have a capricious circle slanted comparative with the plane of the solar system. This expectation of the circle of Planet 9 is like what we are seeing with HD 106906b. Researchers utilizing the impending NASA/ESA/CSA James Webb Space Telescope intend to get extra information on HD 106906b to all the more likely comprehend the planet's framework. Space experts need to know where and how the planet framed and whether the planet has its own trash framework around it, among different inquiries. There are still a great deal of open inquiries concerning this framework, added de Rosa. For instance, we don't decisively have a clue where or how the planet shaped. In spite of the fact that we have made the principal estimation of orbital movement, there are still huge vulnerabilities on the different orbital boundaries. All things considered, the two onlookers and scholars the same will read HD 106906 for quite a long time to come, disentangling the numerous secrets of this striking planetary framework.